Hello everybody and welcome back to Operation Logistics, where once again I've procrastinated this even later than usual. I've only got like an hour to get this uploaded. That's going to be kind of exciting. But in the meantime, we need to keep optimizing startup, implement the load screen, and go after the next world hex. So first things first, the question is, why is this startup so slow? Well, my opinion is that it is generating a single biome hex every frame for every world hex. So it's doing all of this 73 times per world hex. So that's millions of times per frame, right? And then it's going to take it 73 frames to get through all of the biome hexes. So the first thing I would like to do is I would like to not do this. And instead, I would like to bring this back to a void. And we're just going to get rid of the IEnumerator portion, and this is just going to be a return. And then the question is, if we go down here, where is the yield return null? Here it is. We'll get rid of that. And there we go. So now that's back to the way it was. But what I would like to do is in the Hex Manager here, when we do our this here, generate map, create height, create urban. That's what we want to do. So, after we create the height, after we create the urban, we're going to go ahead and do something along the lines of generate biomes. Now that doesn't exist yet, but that's okay. We can go ahead and place that in after the create urban. So we're going to go ahead and place this here, I think. No, we're going to place it here. Public void generate biomes. Okay, and then we're going to need to iterate through the map. So for int I equals 0, I is less than map. Map dot count I++, and then we need another iteration for int j equals 0, j is less than map I dot count j++. Okay, and now what we need to do is we need to, I don't really want to start coroutines here. In fact, I want this to itself be a coroutine. Public IEnumerator. No, not IEnumerable. IEnumerator. Enumerator. There we go. And then we want to yield return null for right there. And of course, we're not generating any biomes right now. But let's just go ahead and come up here, and rather than calling generate biomes, we'll do this as a start coroutine. Generate biomes. And then the question is, how long does each world hex actually take to generate all of the biomes? Well, we'll find out. So in front of this yield return null, we'll go ahead and do map I j dot generate biomes. And now we're going to be doing it for one world hex per frame. And that will allow us to update the loading screen in between those, and overall just see how long this takes to generate one actual biome. I'm gonna guess it doesn't take a huge amount of time, but we'll see. So, how long does this actually take? We have null reference exceptions. That's how long it takes. Ah, yes. This is still a thing. Manager.timeAware_nonMB.add this. So the timeAware object non-MB is not being given an actual time manager. In building.start at building.cs line 142. So that is right here. In base.start. We're clearly assigning the manager before here. But does building have its own manager? No. Okay. So why is manager null here? Well, this is being called then in world hex line 147 and also building.cs line 137. So right here, yep, that's expected. And then world hex line 147. Let's come on in here and check line 147. Building new building equals new building manager.business.time manager. Business is getting its time manager. Where exactly? Well, this is a time-aware object. So it gets it here in awake with a find object of type. So if we come in here, as soon as it compiles back up, there we go, now it's actually responding. We can, we can manually assign this just to make sure that it's actually working. Like so. Now we know for a fact that the business has the right one. And technically we don't need this to happen. But let's go ahead and see if that actually works or not. It may or may not. Looks like it did. Hello? Okay. Okay, so that's going pretty slowly because it is outputting 999 plus of these all the time. And I think that's why. So these debug logs need to go away. Let's go into our world hex. And we don't even need the private void start in world hex anymore. We'll go ahead and delete that for now. And then we'll come on down here and we will go ahead and get rid of all of this. That doesn't need to be happening. That will speed us up substantially since we're not going to be doing all these debug logs. Okay. So it was running quickly at first, and then it slowed down substantially. And that's something we've been noticing, actually. Let's see what we can do about that. So it's running pretty quickly. It's just generally running pretty quickly right now. We've got plenty of FPS going on here to work with for now. Excellent. Yeah, this seems to be fine-ish. I mean, there is the occasional hitch down to 1 FPS, and you can see the... If I skip the tutorial, you can see it going through. It's interesting that that's not actually setting up the... It's not actually going up over top of these ones that are up top. But yeah, you can see it iterating through here, and it's iterating a little slowly. It hitched right there pretty hard. Okay, we are hitting some hitches. But then, if we go over here, and we click on this, I mean, while it's doing that, that's not going to work, because it places it there, and yeah, that's actually not going to work. So, I think at this point, we should go ahead and turn off our main camera, and leave just the UI camera on, and see what kind of FPS we get. Now, if it's going to be running at like 60 FPS, it should do 60 per frame, so it should take under... Yeah, it's going plenty fast. Of course, we have no clear flag, so that's a thing. We have no reference exceptions popping up right now, because the building hex doesn't actually have the strategy camera. Okay, so with that being the case, what if instead we activated the main camera, and can we still grab it if we deactivate just the camera component? Well, that should get the strategy camera script still. Yeah, that should be fine. So we go ahead and run that, and it should render substantially faster. Yeah, that worked. Okay. Yep, that seems fine. So the next thing that I would like to do is turn on the loading screen, like so. And these I would like to turn off, but we don't necessarily want to. I'm not sure how we want to handle that yet. I'll think about that. That's an optimization that we can make in the future. But for right now, let's go into our Hex Manager. And then let's go ahead and, after generating the biomes, we could theoretically go through and populate all of the buildings. Where is that populate building actually called? Is that in the biome hex? No. Is that in the world hex? Generate buildings is here, yeah. Okay. So we can have it generate buildings after, potentially. Or we could just continue to generate those on demand. Yeah, that wouldn't be the worst thing. For right now, let's go ahead and just leave this the way it is. However, we do want to determine our float, or rather our int, total hexes equals, and this is going to be map.count times map_i.count. Since this is square, that'll get us there. And I guess map0.count. And then int current hex equals 0. And then we'll just iterate this down here. Current hex plus equals 1. Okay, and then do we have the loading screen here? Yes, we do. So I'm actually going to delete this here, the list of tasks, and we're just going to have the progress bar for now. We're not going to do an update function. And onfill progress bar, I don't think... well... We'll rename that to onEndLoad. Okay. And then pretty much all we would need to do here is GameObject.setActive false. That would turn off the loading screen. And then we need to get our camera and turn the camera component of it back on. Now I believe we have our camera tagged. Let's see here. Yeah, it's tagged with camera. UI camera is untagged. But let's just go ahead and do GameObject.find main camera. Wow, I cannot type. Main camera. Yep, that's how I spelled it. .get component camera. .enabled equals true. Okay, so onEndLoad is now implemented, and in the Hex Manager, we're going to need to have a reference to this. So let's go ahead and put in a new header down here. Header UI, public load screen, We'll go ahead and assign that in the inspector while I'm thinking about it. So in the Hex Manager, we will need a load screen. Oh, okay. Right. We'll go ahead and move that to the very bottom, because these are not part of the UI, and that made that a little confusing. So we'll move that down. There we go. I mean, they're technically not part of the city settings either, but I guess it'll be fine. We'll put in the load screen, although that doesn't have the loadscreen.cs UI component yet. So load screen, there we go. Now the progress bar is this progress bar. And then there is this TextMesh Pro text here. We'll call that label. And we will go ahead and expose that for right now. So let's go ahead and expose that in load screen. Public tmpro.textmeshprougui label. There we go. So with that exposed there, we'll be able to have access to that via the Hex Manager and change this to whatever we want. We'll go ahead and toss that in there. And then in the Hex Manager, we'll toss in the load screen. There we go. And now the Hex Manager will be able to come on in here. And down in our enumerator, down here, it will be able to say load screen dot progress bar dot update progress bar, and the new progress would then be. We kind of want to cast this over to a float, right? Yes, we do. So float total, or rather float current hex divided by float total hexes. And then the label, we would want that to be basically a percent. So float current hex divided by float total hexes dot toString, and we'll need this in parentheses so that it does the operation and then puts it to a string. And I have completely forgotten E. That's right. Okay, actually, it does that by default. We can delete this. We don't need this at all. That's its default behavior. So just float current hex divided by float total hexes. And we do actually need an extra parenthesis here and an extra closing parenthesis here. And another one? Why would we need another one? I think we just need an end of file, right? Because we've got open, open, close, open, close. Yeah, and then we only have one here. That's what I thought. You were wrong. You were wrong, Visual Studio. Okay, so our load screen is then updated. Let's go ahead and say load screen dot label dot text equals generating. And then we'll put in a parenthesis plus. Actually, let's go ahead and do this way. So we'll do a string dot format, and we're going to pass in generating, and then 0 out of 1, and then we will put in current hex total hexes. Okay, there we go. And we need a closing parenthesis here. Excellent. And then once we finish up our for loops, we should do load screen dot on end load, because at that point we are done with the load. Theoretically, anyway. So let's just test that and see if it works. It should, theoretically. And then the real question is, how long does that actually take to load? The answer appears to be a fair amount of time. But hey, it actually works. So that's great. I'm going to go ahead and put a cut in here, and next episode we'll see if we can find any way to actually optimize this load time. See you all then.